This chapter talks about making decisions in Java. It's similar as making decisions in C++. Decision-making in programming is similar to decision-making in real life. In programming, we also face some situations where we want a certain block of code to be executed when some condition is fulfilled. A programming language uses control statements to control the flow of execution program based on certain conditions. These are used to cause the flow of execution to advance in the branch based on change to the state of the program. If statement is the most simple decision-making statement. It is used to decide whether a certain statement or block of statements will be executed or not. For example, if a certain condition is true, then a block of statement is executed, otherwise not. In this example, we have a if quiz score equal 10. So remember in Java or C++, if you want to have a equal, it must be double equal 10. If you have a single equal, that's assignment. The quiz score equal 10, it's an evaluation. If they're equal, it will return a boolean true. If they're not equal, it will return boolean false. So system.out.println, so we will print line the score is perfect if the quiz score equals 10. If it is false, we will do something else. So the condition after evaluation will be either true or false. If statement accepts Boolean values, if the value is true, then it will execute the block of statement under it. So if there are multiple statements in the block, you should have a curly braces. Otherwise, only the first statement will be executed. So remember curly braces to enclose the multiple statements under the if. I have seen student mistake. For example, in this figure, we have a if, then we have a condition, quiz score equal 10, then there is a semicolon. If you do this, that means the if statement ends. It does nothing. So the next statement, system.out.println, will always be executed, no matter the quiz score equal 10 or not. Don't include the semicolon after the condition. We can use standard relation operator like equal, less, greater than, less equal, greater equal, not equal, to compare the values of a primitive data type, such as an integer or double. But remember, objects cannot be compared. Use less than, greater than, less equal, or greater equal. It will give you a compile error. If you use an equal, not equal, not equal, it will not have compilation error, but it will have a logical error because they are not comparing the values, but they are comparing the object's memory address. In other words, equal yields true for two objects only when they refer to the same object in memory, not when they are different objects with the same value. So when you're comparing the object, remember to use the method to get the object value, then compare them. For example, use a retrieval method, or we call accessor method, to get the data field from an object, and then we compare them. The if statement alone tells us that if a condition is true, it will execute a block of statements. And if the condition is false, it won't. But what if we want to do something else if the condition is false? Here comes the else statement. We can use the else statement with if statement to execute a block of code when the condition is false. In this example, if quiz score equal 10 is true, we will print out the score is perfect. If it is false, so else, we print out it's not perfect. To execute more than one statement, remember use a pair of curly braces to place those statements within a block. and any variable declared within a block is local to that block. In this example, if hours works greater than full week, because there's no curly braces under that, so if it is true, the regular pay equal 4 week multiply rate will be executed. If not, this statement will not be executed. And then the second statement, overtime pay equal hours work minus 4 week, then multiply OT rate, multiply rate. This statement will always be executed because it doesn't belong to the if statement. So remember to use the curly braces if those two statements should be in a same block. A nested if is an if statement that is the target of another if or else. Nested if statement means that an if statement inside an if statement. Java allows us to nest if statements within if statements. In this example, if item sold is greater or equal minimum items, if it is true, then we have another if statement. If total value is greater than or equal to minimum values, then we execute the bonus. We assign the sales bonus to the bonus. The if statement is inside another if statement. And is a type of logical operator and is read as an and or logical and. The operator is used to perform logical AND operations. In the previous example, we used a nested if statement. And we can also use an and. So if those two conditions both are true, we will assign the sales bonus to the bonus variable. The second condition will not be evaluated if the first condition is false. Double vertical bar is a type of a logical operator and is read as or logical or. This operator is used to perform logical or operation. The second condition is not evaluated if the first one is true. So either one is true, the statement will be executed. If the first one is true, the second one will not be evaluated because the statement will be executed. If the first condition is false, then the second one will be evaluated. If the second one is also false, the statement will not be executed. If the second one is true, the statement will be executed. In this example, we have a if item bought greater equal minimum items or items value greater or equal minimum values. So either one is true, that we will assign the discount to the discount rate. A range check is a series of statements that determine to which of several consecutive series of value another value falls. So consider this situation in which salespeople can receive one of three possible commission rates based on their sales. If the sale is a 1,000 or more, the commission rate is 8%. If the sales is between 500 to 999, the commission rate is 6%. If it's less than 500, the sales commission is 5%. So if we use this three if statement, there will be logical errors. For example, for the second if sales amount greater or equals than medium limit, so for this one, the sales amount greater than high limit will also fall in this category. We should use if, else if. So a user can decide among multiple options. The if statements are executed from the top down. As soon as one of the conditions controlling the if is true, the statement associated with that if is executed, and the rest of the if statement is bypassed. If none of the conditions are true, then the final else statement will be executed. It is most efficient to ask a question that is most likely to be true first. If we know that the most sales amount values are high, compare sales amount to high limit first. If, however, we know that the most sales amounts are small, we should ask if sales amount less than low limit first. So this code in this figure results the same commission values for any given sales amount, but the sequence of decisions is more efficient when most sales amount values are small. The switch statement is a multi-way branch statement. It provides an easy way to dispatch execution to different parts of code based on the evaluation of the expression. The expression after the keyword switch, in this case, it's a year. The expression can be of any byte, short, integer, character, or an enumeration. Expression can also be a string type. You cannot have a duplicate case values, right? Case value 1, case value 2. The value 1 and the value 2 cannot be duplicated. The default statement is optional. The break statement is used inside the switch to terminate a statement sequence. So when a match is found and job is done, it's time for a break. There's no need for more testing. So a break can save a lot of execution time when it ignores the execution of all the rest of the code in the switch block. The break statement is optional. If the break is omitted, execution will continue on to the next case. So switch statements are convenient when several alternative courses or action depend on a single integer character or string value. So we should use them when there is a reasonable number of specific matching values to be tested. If you don't have matching values, we shouldn't use switch statements. The meaning of a ternary is composed of three parts. The ternary operator (:) consists of three operands. It is used to evaluate Boolean expressions. The operator decides which value will be assigned to the variable. It is the only condition operator that accepts three operands. It can be used instead of the if-else statement. So the syntax is a variable equal. We first evaluate the condition. Then we have a question mark. If the condition is true, we will assign the expression 1. If the condition is false, we will assign the expression 2. So in this example, we have a x equal 20. And the next statement, we say y equal x equal 1. So x equal 1 will be evaluated. Because x we know is 20, so x equal 1 will return false. So the 90 will be assigned to y. If x equal 1 return true, 61 will be assigned to y. We use not operator, which is written as the exclamation point, to negate the results of any Boolean expression. Any expression that evaluates as a true becomes false when preceded by the not operator, and accordingly, any false expression preceded by the not operator becomes true. You can combine any number of NN or OR operations in an expression, but we must remember those operators, they have a precedence. The highest one is the not operator, so the not will be evaluated first. Then the arithmetic is done, and we know from algebra usage the multiplication, division modules will be done before addition and subtraction. Then we have a relational, we have a equality, and the end, logical end, should be done before the logical OR. So statements in parentheses are evaluated first, and the assignment is then the last. In this example, we consider the program segments. Those code segments are intended to be part of an insurance company program that determines whether an additional premium should be charged to a driver who meets both of the following conditions. The first criteria is has more than 2 traffic tickets or is under 25 years old. The second criteria is male. So the first segment, the NN operator is evaluated first. So actually the age less than 25 and gender equal and male is evaluated first. So this is not the first criteria. The correct criteria is more than 2 traffic tickets or is under 25 years old. So we should use a parenthesis like the second code segment. So we use a parenthesis and to enclose traffic tickets greater than 2 or age less than 25. So this expression within the inner parenthesis will be evaluated first. We can use decision making to control the allowed values in object fields. Whether values are assigned to the object by constructor or by mutator methods, we can use decision to restrict the values assigned to the fields. For example, we create an employee class, as shown in this figure. The class contains 2 fields that hold employee number and pay rate. So we have a private integer employee num and a private double pay rate. The constructor accepts values for these fields as parameters, but instead of simply assigning the parameters to the field, the code determines whether each value is within the allowed limits for the field. So in the constructor employee, we have parameter num and another rate. So if this num is less than or equal to maximum employee num, maximum employee num is a integer. We set the value like a 999. If it is within the limit, the parameter is within the limit, we can assign the value of the parameter to the employee num, field data employee num. If it is not, it's beyond the limit, then we just assign the limit, the max employee num to employee num.